Well, hello Internet, and welcome to my Object Pascal tutorial. In this one video, I'm going to cover the core language and the core concepts you need to understand to program with Object Pascal. And I'll also be exploring some capabilities with Delphi using Embarcadero's software. And I have a lot to do, so let's get into it. Okay, so I'm just going to go through the installation process here very quickly because it's very easy. All you need to do is go to Embarcadero and products, and specifically what you're looking for is Delphi. This is all free. However, as far as I know, you have to enter your information here to be able to download it. Of course, you can go use other software. That's what I chose to use in this because it is free. And one cool thing about this whole development platform is with Object Pascal and Delphi, it basically is going to combine the capabilities of object-oriented programming with procedural programming. And what is really great about it is, as you can see right here, you can develop for every platform: Windows, Mac, iOS, and Android. So really great stuff. So just click on download now after you enter your information. It's going to say that it's downloaded, so you just go and open it up so that you can go and enter the installation. Now this is all done in Windows. Then you can choose over here what specifically you want to download for. I just chose Windows and iOS in this situation. Hit continue. I didn't choose to import any of these, and I clicked on install. And it's going to install on your system, of course. And after it's done, you're going to see little messages pop up like this. I'm just going to come in and make sure we have this checked and click on OK. And then you can either choose a light or dark theme. I decided I preferred dark. Click on next. I didn't choose to do anything in regards here, since it's just a basic tutorial. Keep everything as set and click on get started. Whenever you do, you're going to see something like this. I'll zoom in here. And one of the things you may want to do is increase your font size. I'm going to show you how easy that is to do. Just click on Tools and Options, and you're going to see something like this pop up. Now, what is great here is whatever you're searching for, you can just type it up here. In my situation, I wanted to increase the font size. So I typed in font, went to editor font, clicked on that. This pops up, changed it to 18, and I liked it. All right. So that's how simple changing options and such are. So click on save. And what you're going to do is you're going to say that you want to create a new project. Something's going to pop up that looks like this. And what I chose to do is just to focus in on Object Pascal. I'm going to leave it to you guys. If this video gets a lot of views, or if you request it, I will get into all of the other capabilities. But for now, I want to teach Object Pascal, so I'm just going to create console applications. So click on OK, and this is what you're going to see. All right, so there you go. And now I'm going to jump over and start writing code. All right, so I renamed this project 4. That's the only thing that changed right here. And basically, the program's name is the same as your file's name. And basically, a Delphi app can have multiple units, but only one program file. And we'll cover units later on. Now, basically, what are the basic things we need to know whenever we're first learning how to program with a language? Well, the first thing is, of course, a comment. All right, there's a couple different ways. So you can just have a comment like that, like is common with C++ and such. You can also have multi-line comments. So multi-line comment like this. And another multi-line comment option. Another, whoops, you want to put a little parentheses like that. Another multi-line. Exactly like this. All right, so there are your different, and you can click on save if you'd like. All right, so another multi-line comment. There's multiple different ways to create comments. Now with Object Pascal, your statements are going to end with a semicolon most of the time. And one thing that's very important is that white space is ignored, and also your variable names and functions and such are going to be case insensitive. So those are just some things to get used to. All right, what are we saying right here with this line of code? App type console. Well, in this situation, this is called a compiler directive, and it defines that this app is going to run in the console, as you will see very soon. This guy right here on the next line is going to include an external resource file, and the star that is right there is going to use the source file's name in this situation. Uses, these are going to be all of the other units that you are going to need for your program to work. And I am going to abbreviate this to system utils, and I'm also going to go VCL dialogues. These are all just different functions that are going to, allow you to do so much more with a language. This is going to allow me to work with character types, and these are a whole bunch of math functions. For now, those are the only units that I'm going to be using. Now, you are going to be defining or declaring your variables after var, right like that. And you can just declare a variable. Just for example, let's say we want a string. I'm going to call this string text of type string and end it with a semicolon, exactly like that. Now, variable names can start with a letter or an underscore, and they are going to be able to contain letters and numbers as well as underscores. And it's very important to understand that your variable names are case insensitive. So for example, my var like that is going to be the same as my var like that. Okay? So case insensitive. And I'm just going to jump right to it and cover all of the different data types that are available to you. All right. So we already saw our strings, which are just strings of characters and numbers. We also have integers, and you can see exactly how to define them. You just put a colon after whatever your variable name is, followed with the data type. Integers, this is the minimum integer value. This is the maximum integer value. And you're going to see a lot of situations where data types have different names, but they actually have the same minimums and maximums. So, for example, an integer is the same as a long int. Then you have your character types. They're going to go from 0 to 255. And again, a byte and a unsigned int is also going to be the same, hold the same number of values as a character. With Object Pascal, you're going to have booleans that are either going to have a true or a false value. So we're not going to have ones and zeros like you see commonly in other languages. You're also going to have doubles. You can see they are very, very small and very, very big. And they are going to have precision between 15 to 16 digits, which is going to be roughly the same as other languages. You can also use a real type in this situation if you prefer to use those instead of doubles. We also have short ints, which have a negative value of 128, maximum value of 127. Again, you can see same as int 8. And also under this video in the description, I'm going to have a link to all this code so you can just copy and paste it and use it as a cheat sheet if you'd like. We're also going to have words, which are going to have min of 0, max of 65,000 roughly. You're going to have small ints, which are going to fall within those ranges. Well, actually negative 32,000, positive 32,000, and then int 64 and currency. Those are the major data types you are going to deal with and their different derivative names. And as the tutorial continues, I'm going to use these different variables down here inside of my code. You are also going to have user-defined data types. And to put those in here, you just come right after uses, but before var, and you just type in type, like that. And we can define things such as arrays, which are, I'll get more into them later on, but basically an array just stores multiple values and is assigned one variable name, okay? So if we wanted to define our personal type, we could say that is an array. We could say that we want an array and we want it to have indexes of 1 up to 10. Then you can only store one type inside of an array. And in this situation, I'm going to say that that is an integer type. We can also create what are called dynamic arrays, which have the ability to change size. And I'm just going to call this dynamic array. And then you're going to come in and say, like this, array of integer. Again, there is how to create both of those different types of arrays. Now, after you have defined these guys, you can come down into your var section and declare your personal user-defined types. So I'm going to say my array is going to be a custom int array. And you can see here, up inside of here, it is called int array. That is a custom type. I am now using that custom type to create an array down inside of the var section. Now, dynamic again. So let's say dynamic array and dyn array, like that. All right. You can also come in and let's say that you would want to make a multi-dimensional array. Well, let's just call this mult array, like this. You would say array, and let's say you would want to have indexes from 0 to 3 and 0 to 2. Just to be different, you have to say of integer, like that. All right, so multiple different ways of defining arrays. Another thing I want to do is I want to create a couple other integers that are just going to be used for cycling and such whenever we get into that topic. All right, so I'm going to say w, x, and y, and these are going to all be integer types. Now we get into writing some real code, and we're going to do that down inside of here between where we have begin and end. And I am going to set this up inside of a try block for exception handling. So any errors that we get are automatically going to be shown inside of our console to catch them and provide us with additional information in regards to what caused our program to crash. All right, so I'm going to first show you the assignment operator. So I'm going to go string and text, like that, and I'm going to say hello Pascal, like that. And there you go. And here is our assignment operator. And of course, it assigns the string hello Pascal to our string called string text. And if you don't remember, string text up here is a string, and that's where we defined it. All right, so everything is compartmentalized inside of Object Pascal. So we could come in and we could say that we wanted to print this information out on our screen just by going right line and string text. Come up here, hit run, and it will display in the console. But it will display so extremely quickly that you will not see it. If you want to pause it, we're going to get into receiving user input here in a second. But if you want to pause the screen so you can actually see what's in the console, you're going to have to come in here and say read line, like that. And that will just keep the console open until you hit enter. So there is hello Pascal, exactly as we would like it to be. All right, and then you can just hit enter and the program ends. Once again, the read line pauses the console from continuing. It's waiting for some type of user input to finally close the console. So very important, if your console is opening and you don't see it, that's what's going on. All right, let's continue. So let's say right line automatically adds a new line after it prints out hello Pascal. Let's say that you would not want to add a new line. For example, if you wanted to ask the user for some type of input. So we could say, what is your name, like this, and there we are. And then we could receive input from the user. So I could say read line, and I want to store it inside of our variable string text. You can go and change the values that are assigned to these different data types. I'm not going to spend a lot of time with dialog boxes and things like that, but what the heck, I'll just show you one of them here. So I'll say show message, like that, and let's say we would like to say to our user that we would like to say hello to them. So we'll say string and text, exactly like that. Now if we come up and we run our application, it's going to say to us, what is your name? And I tell it my name. I hit enter, and it pops up a little dialog box saying hello Derek. All right, it's very, very easy to do GUI development with Delphi and Object Pascal. Extremely easy. All right, so right line, and let's say that we would want to find out the number of bytes for one of our data types here before we move on, something that is commonly asked for. So let's say we wanted to find out for an integer. You can do this for any of the other data types. You can just say size and then call toString, which is going to convert that integer into a string that we can print out on our screen. And just so we don't have any of this going on, I'm just going to go and get rid of it. So let's just comment these lines out so we don't have dialog boxes and things like that popping up on the screen. And we can come in and run it, and you can see that it comes back to 4 bytes. All right, so neat stuff. Now let's get into casting, because it's going to be very important to cast to the proper data types. So I already defined age up inside of my variable section. And let's say I go and give this a value of 45. And I'm going to convert 2 different types. So I'm going to say right line like this. And let's say I want to convert this integer age into a string. Well, I go age and to string, exactly like that. And let's go and do some other ones. So I'm going to just go in here, copy this, and jump to the next line. And what else do I want to do? Let's do 2 more. Let's say I would like to convert this into a Boolean. What would happen if I do that? Well, we're going to find out. So that will convert any data type into a Boolean. You can also do toDouble. So we'll go toDouble like that. And let's go and do another one. Let's go and get canVote, which is a Boolean type that I defined in the variable section. I am going to give it a value of true. And then I'm going to come in and output this information. And if I would want to convert from a Boolean to a string, I say bool to string like that. And it's very important to enter true at the end. So it's going to get whatever the value of canVote is, and then it is going to output true as we would expect it. And I forgot a parentheses. That's why I have that error right there. And let's go and run it so that you can see. And you can see exactly how we converted to these different data types. So neat stuff. Let's do some more conversions. So if you would like to cast a string to a number, let's go and get string num like that and give it a value of 50. And we want to go and output this. We'll say right line. You would go string to int like that and string number like that. I'm just going to continue on here because I think you understand. Basically, here is how we could convert into other different types. So you can go and experiment with that on your own. You use CHR to convert numbers to characters. Trunc converts reals into integers. String to float converts string to float. And float to string, of course, converts floats to strings. All right? And that brings us to the numerous character operations that are available. Again, you're going to use character. This unit right here is required. And I am specifically going to be using grade, which is of type character. All right, so let's just come in here and start working with them. So let's say I take grade and I assign to it the character of A, of course. And then let's say that I want to check what type of character it is. So I could come in and say right line, and I could check, is it a digit? And pass grade inside of it to find that out. I can then, let's just go and copy this, because I am going to show you how to check a whole bunch of things. Very useful information. All right, so we got all that. So we can check if it is a digit. We can check if it contains letters. We can check if it is all lowercase. We can check also with is upper, if it is all uppercase. We can check if it is white space, just by saying white space. See, very easy to remember. Another thing we can do is let's go and get rid of this part right here. And let's say that we would like to get the character code with this. Well, we could just go CHR. We could get the character for the character code of 94 and put in that extra parentheses. And what else can we do here? Let's go and do one more example. Let's say that we would like the character code for the letter A. We could also get that. And if we run it, you're going to see all of that additional information that pops up. All right, so you can see here that the character for the character code is 94. You're also seeing here that it comes back, is it a digit? And it comes back false. Is it a letter? It comes back true. And so forth and so on with the rest of that output. And I think that's all I want to cover in regards to characters for now. A little bit more later. Now I'd like to talk about some math operators. All right, so of course, we're going to be able to come in here and perform multiple different math operations. So we could do something like 5 plus 4 is equal to, and then just put in a comma, and 5 plus 4. Very simple. Exactly the way that you would think it would work is exactly the way it does work. So let's go and throw in a couple more of these. And I think 5 is probably enough. So let's go and 5 minus 4. And of course, you just change this to minus. And of course, we can do multiplication and multiplication. And we can do division and division. And also, let's go and we can use modulus to get the remainder of a division. In this situation, just make sure you put a space inside of there like that. And let's go and drop in another one like this. And let's say that we wanted to do integer division. We just do div like that and div like that. And of course, if we run it, we're going to get exactly the output that we would be expecting here. All right, so neat stuff. Another thing is we're going to be able to decrement and increment quite easily. So let's say I want to decrement my age. If it only was so much easier, I just go dec age, exactly like that. And I could do a right line here and output the age, of course, like this, and age. And then maybe I want to increment my age. I have no idea why I'd ever want to do that, but let's throw it in here. We can just increment that integer value of age once again. There's also going to be a ton of different math functions built in. I am going to cover the majority of them. Now you need math up here inside of uses to be able to use all of these functions. And I am just going to output them here. So I'm going to say math functions. And then I will go through them all. All right, a whole bunch of them. Okay, so what types of functions are built in? Well, we have ceiling. What's it going to do? It's going to round this up. It doesn't matter what comes after the decimal place. 3.14 is going to be rounded up to 4. Then you have floor. No matter what this value is, it's going to round it down to 3 in this situation. You can pass in multiple values. As you can see here, it'll give you the maximum value. We can also do min. Again, it's going to give you the minimum value. We can go and get the power. In this situation, this would be 2 to the power of 3. We're going to be able to easily generate random values. So if you want random values between 0 and 10, you just type in random range 0 to 10, done. You don't need to seed anything. You don't need to do anything else. Let's say we would like to compare values. And you're going to see we can use this function later on with other data types. Well, you can compare 5 to 4 in situations in which A, meaning the first value passed in, is less than B. You're going to get a -1. And in situations which they're equal, you'll get 0. And in the other situation, you will get 1 as a passed value. And you can go and convert degrees into radians just by going degree to radian. You can go and change this to uppercase D if you'd like. Do whatever you'd like. Case insensitive, remember. You can also convert radians to degrees. There's also multiple different logarithmic functions. I'm not going to go into the specifics, but there's notes in regards to how logarithms work if you're unaware, which, you know, a lot of people are. If you don't use logarithms all the time, probably don't know how they work. So there's just a note on exactly the different logarithms. You're going to be able to find the hypotenuse by going and passing in 2 values. You can check if a value is infinite. You're also going to be able to check if a value is going to give you a value of 0, and check if the value is not a number. and so forth and so on. You're also going to have multiple different trigonometric functions, and you can see examples of all of those and the variable names or the function names for all of those different types of trig functions. And if we go and run it, of course, you're going to see pretty much exactly what you would be expecting to see. So there is ceiling and floor, max, min, power, random, da 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 da. All right, so whole bunch of information. We'll get into formatted output here very, very soon. But up next, I want to talk about conditionals. All right, so in regards to conditionals, you're going to have your relational operators, which are going to be just a single equal sign. This is going to represent not equal. And then, of course, I'm sure you're probably aware of less than, greater than, less than or equal to, greater than or equal. Then you're also going to have logical operators, and they are going to be and, or not. And I'm going to show you how all of those work using multiple different examples now. So let's say we said to the user that we want their age, because what we want to do is decide if their birthday is going to be important or not. So I'm going to say, what is your age? And like this, and receive input from the user. Remember, write does not add a new line. We can then say read line and store that value inside of the variable age. Then we get to if, else if, and else statements. So using our relational operators and our logical operators with if, else if, and else, we're going to be able to define if a birthday is important or not, based off of my weird understanding. Whoops, I don't need this. All right, so there we go. So I'm going to say if, and you can see then automatically pops up. I'm going to say if the age of the individual is greater than or equal to 1, and there is our logical operator and the age is less than or equal to 18. Well, in that situation, then what we want to do is we want to say that this is an important birthday. So we will say right line and important birthday. And there we go. All right. Oops. And you do not put that semicolon inside of there. Let's say we want to check another condition. If this is not true, then we will also check this condition. This condition in this situation is going to be if age is equal to 21. And this example is silly, I know that. It is specifically structured just so I can show you all these different operators. That's the only reason I chose it. Okay, so if the age is equal to 21 or it is equal to 50, well, in that situation, then what I want to do is I want to say that, yes, this is an important birthday. So I'm going to go and copy that, paste this here, drop it inside of there. So another important birthday. I'm also going to pay respect to my elders. I'm going to say else if and age is greater than or equal to 65. Well, in that situation, whoops, I keep doing that. Let's just get rid of this. All right, so doink and throw this over here. Okay, if they are greater than 65, then once again, I am going to say that this is an important birthday. Otherwise, this else statement is going to be the catch-all. If none of the other things came back as important birthdays, well, I'm going to say not an important birthday. Sorry about that, but that's the way it is. And don't forget your semicolon. Now we can come in and we can go and run this. And down here, you can see, probably can't see, what is your age? And if I type in my age, boom, not an important birthday. And I am sad. All right, so there you go. That is how we can use if, else, and conditional operators, logical operators, and a whole bunch more. Now I'd like to talk about case. So another conditional tool that's available to us. So let's say we say that grade, if I can spell grade right, grade is going to be equal to a B. All right, so we got that. Well, what we can do is we can say, this is like switch in other languages. We can say, keep doing that. Let's stop doing it. All right, so grade is equal to, and I'm going to say case grade of, Well, what we can do is we can say if it is an A, that is the value of grade. Well, in that situation, what I want to do is I want to go right line, and I will say awesome. All right, and that is what will be output on our screen. If we can also put multiple different values inside of here, so we could say B and C. So if you got a B or a C, well, in that situation, we could say right line, and let's say you're a mean parent, you say do better, okay? Then you have D, and in this situation, you would say right line, and you would say terrible, okay? And then finally, we could say F, and we could just cut to the chase and say that this student is a failure. Okay, so there you are. And you can see it's very important to have N down here, but the IDE automatically goes and does that for us. So that's good. And we could come in and get rid of this. I think I already have age inside of here, so I can just comment this out and it won't ask me for age. Let's see if I get an error. No, I didn't. And you can see that do better comes back here as output. So multiple different ways of working with those. And another thing that's important and very, very useful is with case, you are actually going to be able to use ranges instead of just individual letters or going and putting B, C, like let's say you wanted B, C, D, and so forth and so on. Well, there is the range capability, and you can actually, instead of putting A like that, you could do something like A like this, and let's say you wanted to catch all letters between A and T for some reason. There you go, and you can do ranges, and of course you can also do ranges with numbers just by going and putting those two little dots in there. All right, so now let's talk about arrays. Now, an array, there's multiple different types of arrays, but first we're going to talk about fixed size collections of data of the same type. And you can remember, I think, whenever we defined our arrays. See, we have my array, which is an int array. We have a dynamic array. We have a multi-dimensional array. And if we come up here, let's go to this part. You can see that we wanted an array that's going to have indexes or the ability to put 10 values inside of it. And this is a dynamic array, which allows us to change the different types of different amounts of values that we put inside of it. And if we come down inside of here, where is it? Oh, there it is. This is where we actually declare those different arrays. And there's a multi-dimensional array as well. All right. Now, if you would want to assign a value to a index, you just go, put them inside of your brackets like that. And let's say you just want to assign a value of 0. And you put the assignment operator. There you go. All right. Now, if you want to retrieve that value, again, very easy to do. So let's say we just want to have this be array, whatever is in index 0, exactly like that. We can come in and go and get that value by calling my array and 1. And then in this situation, if I want to convert this into a string, remember we have to use toString. And if you want to set the size of a dynamic array, you can just go set length like this and d array like that. And let's say you want to have 5 values inside of it. There you go. Now you can put 5 different values inside of that dynamic array. Now I'd like to do more with arrays, and I will, but to do so, I need to cover looping. So let's just cover looping right now with our arrays. Multiple different ways to loop. 3. Actually, there's even more than that. Okay, so what we're going to do here with looping is I'm going to show you how to initialize an array with just some values using a for loop. So what we're going to do is we're going to say for, and I'm going to say W, and then hit tab, and I'm going to say that I want to go from 1, hit tab, to 5. All right, so there you go. There is our for loop. And of course, it's going to start with a value of 1, then go to 2, 3, 4, and 5. Now, what I'm going to do is go my array, and I'm going to use W, which has a value of 1 to start off, and I'm going to assign that 1 to the index of 1. And there you go. That is how you initialize an array and just add values to it. Well, how do you retrieve array values? Well, you can use a for loop again. So, again, we're going to use W, and then I'm going to say I want to go from 1 to 5 again. And then afterwards, I am going to just go and output all of those values. So I can say my array and like this with a colon, and I can go and get each of those individual values out of my array, just like you would use other languages. Pretty standard way of working with for loops. And if we run it, you're going to see that we indeed get 1, 2, 3, 4, 5. All right, that's exactly what we expected, and that's exactly what we got. Now, you're also going to be able to initialize as well as display multi-dimensional arrays. So I'm going to use multiple for loops for this guy, and I'm going to say W in this situation, and remember we did 1 to 3 with it. If you don't remember, take a look at the code. So, and it probably helps just to download the code that I provide. It's free, so why not? And I'm going to say W, and I'm also going to have this be X, and it goes from 1 to 2 in this situation. And then to initialize this, I can just say mult array, and using the indexes. So it's going to be W and X like that. And then I can go and assign, let's say I want to add whatever the value of W and X is, and store those inside of there. That's how you do it. Now, likewise, if I would like to come in here and output this information, well, I can just go and copy this, and we can jump down to our next line, and we can output that multi-dimensional array using exactly the same for loop. And the only difference is we're going to say write line like this, and then inside of here, we'll say mult array like that, and W and X for the indexes, and then we can run it. And you can see that it comes back, it adds those values together, and how it puts them in the multi-dimensional array. All right, and what's going on here is it just goes, this gets a value of 1, and then it goes and finds out what those 2 columns are inside of there. And then it goes to 2, and then it gets the 2 that are assigned to it. Then this goes to 3, and then it gets the final 2. All right, so that's multi-dimensional arrays inside of Object Pascal. Another option you have is what we call a while loop. And you're going to be using a while loop anytime that you don't know how many times. It's normally a condition is going to end your while loop. So what I want to do with this while loop is I want to cycle through values, and I want to print odd values up to 13. So very important, you're going to always have a variable that is defined outside of your while loop. And here I'm going to say while W is less than or equal to 20, and I'm also going to cover break and continue and how they work. Now, if you want to be able to perform multiple different options inside of a loop or a condition or anything like that, you're going to have to type in begin like that and end right there. Now, what we're going to do is we're going to say that W, actually, you know what? Let's do if, and in this situation, I'm going to say W mod and 2. So in this situation, if this comes back as true, if I have 0 inside of there, well, in that situation, we know it is an even value. I want to do multiple things now. So what do? I have to type in begin. Again, remember that. You always, anytime you have multiple different blocks of code or lines of code to execute inside of any of these conditions, if blocks, while loops, any of those things, you have to put begin and end inside of it. So what are we going to do? Well, I have no interest in printing out odd or even values. I only want to print out odd values. So I need to increment the value of W so that we go on to the next value because we don't like this one. And then we can call continue. And what continue does is continue is going to jump back up to the loop. Now W has a new value, 1 more than what it was before. It's going to jump up here, and then it's going to check if it's an even value again. That's what continue does. Jumps back up here and continues. All right? So it's right into the name. Well, then what do we have? Well, we have another condition. So we're going to say if what I want to do is I want to jump out and only print values up to 13. Well, how do I do that? Well, I can say if W is equal to 15. Well, I don't want to print anything, and I want to jump out of the loop 100%. Don't want to execute any more code in it. Well, in that situation, I type in break. That's what break does. It says I don't want to be in this loop anymore. I want to break, and I want to go down here, outside of said loop. But I still want to print all of my odd values. So to print those odd values, you just go right line, of course, and I'm just going to say W just to keep this simple. And I am going to show each of those values for W. And then, of course, I need to, because we're still in the loop, I need to increment the value of W, exactly like that. And if we run it, you're going to see that we printed out all of the odd values just like we wanted, and we stopped at 13, just like we wanted. All right? So there you go. That is how while loops work. And now I want to talk about repeat until. Now I'm going to do something a little bit more interesting with repeat until. What we're going to do here is we are going to create a guessing game. So I'm going to get W and assign to it a random value. Well, how do I do that? Random range. And 0 to 10 is the range I want to use for my random value. This is the number we're going to try to guess. And X in this situation is going to represent our guess at this random value. And you may be able to guess exactly what repeat until does. It basically repeats executing over and over again until a condition is met. And what is that condition? We're going to loop until W is equal to X. That is what we are shooting for. Now, let's come in, and I'm going to ask the user to guess a number. So I'm going to say, guess the number. And put this inside of there, exactly like that, and we will continue. Of course, I need to come in and read a value from them. I'm going to store that in X like I talked about before. And let's say I would like to help them solve this problem. Well, if X is greater than the value for W, well, in that situation, I'm going to say, then I want to output onto the screen that the number they entered was too big. I'm also going to say if X is less than W, well, in that situation, I'm going to output on the screen that the value they entered was too small. Exactly like that. And the until is just going to end if they're equal. And if they ever do, they will, unless they're really silly, they're going to eventually get out of this repeat until loop. And when they do, that means they guessed it. So I'm going to say you guessed it. And with an exclamation mark, of course. So there we are. And we can come in and run this, and we can test out exactly what to do here. So I'm going to say, guess a number between 0 and 10. I'm going to say 5. Too small, so I'm going to say 7. Too small, so I'm going to say 9. Too big, well, obviously it's 8, and I guessed it. All right, so there you go. That is how we work with different looping options inside of Object Pascal. And I want to talk about some other user-defined types. So I'm going to define some user-defined types. Where do I do that? What's that section of the program called? See if you can guess it. It is type. There it is. So let's say that I would like to define a special type, and I'm going to call this T grades, and I want them to fall within a range. So I'm going to say that the range is going to be A through, let's say that they don't have F, so let's just do E, okay? Just to do something. All right, so there is my user-defined type between A and E. We're also going to be able to define what are called enumerated types. And enumerated types have values that are assigned a number that starts with 0. So let's say that I also want a user-defined type based off of days. And I'm going to just go Monday, Tuesday, Wednesday, Thursday, and Friday, like that. And I'm going to use these here in a second. All right, another type, which is interesting, are what are called set types. So let's say I would want to model playing cards, like for poker. Well, what set types do, set types are groups of values where a set can contain multiples of those values. So I'm going to say that I want to define a card, and the card can have a value of 1 and 2. Whoops, let's go 2, 3, 4, 5. I'm not typing the numbers in because you're not allowed to store those. That's the reason why I'm actually typing the actual numbers out, if you're wondering why I'm doing that. 7 and 8 and 9 and 10. And now that you have proof that I actually know how to count, there you go. We also have jacks and queens and kings and aces. And there you go. Those are the different values I have assigned to a T card, which is my custom type. Well, then you have to define T cards, which is going to be a set of T card. And I'm going to model out the actual playing cards that somebody would have in their hand. All right, so those are all the user-defined types I'm going to do, or I'm going to cover at this point. However, you're now going to have to go down inside of var, right in here roughly, and you're going to have to define these types. So I'm going to have a my grade, which is going to be of T grades as I define them. I am also going to have my favorite day, which is going to be from T days, like that. I'm also going to define my set type. So I'm going to have a playing card hand. This is going to be my cards, like this. And then another hand, a competitor maybe, or something like that. So T cards like this. And let's say I have an extra hand, because there's some other things I want to do with sets. So I'm going to say extra hand. I can also hold one individual card like this. I'm also going to have card string like this, and this is going to be used for card output. And I'm also going to define a card array, just to really mess around here. And the array is going to be made up of T card types. And I'm going to say of string, and I'm going to put 14 inside of there. And it is going to be equal to all of the values up there, but I have to put them inside of quotes. So I'm going to cheat a little bit here, and I'm going to copy all of this. So go and get all of that stuff and copy it and come down inside of here and paste that inside of there. So right like this, and then what we can do, well, I can just keep this right here. So I'm going to go 1. So I'm going to go and put quotes around all of these individual little guys inside of here. All right, so every single one of them has been quoted, and you're going to see in a second here exactly why I did that. So let's get down inside of our coding section that we have inside of here. So just scroll down. All right, so here we go. All right, so what am I going to do first? Well, I'm going to use my user-defined type, my grade. I'm going to go my grade, and I'm going to assign an A, of course. And I can then go right line, and I can go and output my grade is equal to, like this, and output my grade, which I think you're going to know exactly how that works. And of course, you have to put the assignment operator inside of there. And if you would like to store our custom enumerated type inside of our variable favorite day, you just go T, days, and Friday, of course. And that brings us to, well, let's go and output this just so you can see what it looks like. And of course, whoops, guess a number shows up. Whoops, didn't mean to do that. I guessed it pretty quick. And you can see that it comes out as my grade A. All right, so good stuff. Now let's talk about sets and how we're going to mess around with those different cards that we stored inside of there. Okay, so a set can actually contain multiple values. So what I'm going to do is I'm going to say that my hand to start out that was drawn for me is going to contain 2 and 4 and Jack, Queen, and King. Not a bad hand. Whoops, there we are. So there you go. That's my starting poker hand that I have. Well, you're going to be able to add as well as subtract values from sets very easily and then reassign them. So I'm going to say my hand like this. And let's say that you would like to subtract 2 and 4 from it and get a 10 and an ace. That would be great. Well, you can do that. So my hand minus, and you just put in what you want to get rid of. So 2 and 4 like that. And then what you want to add to it is 10 and ace. And that's what you just did. And there you go. So it's that easy. Now you're going to be able to do a lot of things here. So let's say you would want to get the union of 2 sets. Well, let's go and get other hand and assign it some values. So we'll throw 4, 2, 10, Jack, and ace inside of there. So there's our other hand. And then we can have our extra hand as well. And we're going to say that it contains my hand plus the other hand, like that. And that will give us the union of both of those. Likewise, you're going to be able to get the difference. So you can say extra hand, and it's just going to be my hand minus other hand, like that. You're also going to be able to get an intersection between those hands. Let's just copy this just by putting in the multiplication sign in this situation. You can go mess around with the output from these different functions and check them out, see what happens. I'm also going to use right line in this situation, and you can find out if the sets are equal or not equal. So I'm going to say my hand, is it equal to other hand, like this. And let's just go and do this. And inequality, see if you remember what that is. It's just this operator right there. Likewise, you're also going to be able to check if a set is a subset, and you do less than or equal to. And you can also check if a value is inside of a set. And how you do that is you just say, let's say is 1 inside of extra hand, like that. And if we run it, you can see that we get false, true, false, and false. Okay? And let me go and get rid of this guessing game here. Now you're also going to be able to cycle through all possible values that are defined for a set. And this is where the card string is going to come in. I'm going to give it a nothing value here to start out. And then I'm going to cycle through. And I'm going to say one card is going to be equal to. So one card. And we're going to go from 1 to A, which is representative for the ace. Now, if the value is in extra hand, which we'll check with if one card in extra hand, well, then in that situation, add it to our output string. And we're going to do multiple things inside of this if block. So we're going to go begin and end, of course. And here I will go card string is equal to card string plus, and then I'm going to put a space inside of here. Now what I can do is get the index and then match it up to my string version. So this is the reason why I did this. See? The indexes are exactly the same. So I can go get this index, match it up to this string, and then output that string from it. All right. So how are we going to do that? Well, I'm going to say card string equal to whatever card string is plus and card array using the same index, which is assigned to one card in this situation. And then after I cycle through with the for loop in this situation, I can go and call write line exactly like this and go and print out the card string exactly like that. And if we run it, you can see that it prints out 10, Jack, and Ace. All right, so there's a rundown of multiple different things you can do with sets. And now what I want to talk about is dates. Now, you don't need to do anything particularly special here. Don't even need uses or anything. So let's come down here inside of the variable section. I'm going to get the current time. This is going to be now time. And it is of t date time. And then I'm going to define year and month and days. And these are all going to be word types. And another thing is constant assignments are also defined in the var section right here. So if you wanted to define a global in this situation, which would be a value that would be available anywhere in this whole entire file, this whole program, well, you just go I am global like this and integer and define this in our var section. So 10, there you go. There's a global. And a constant is going to just be constant. And let's say we want to use pi in this situation, which is a double, and give it a value of 3.14, even though it's not very accurate. Good enough. All right. So that's how we define globals inside of R and constants. And here's our date time types. And I'm going to show you how to work with date times now. Now, if I want to get the current, like right now time, I just go now time and assign it the value of now. Pretty simple. And I can go and output the current time from this. So I'm just going to call this current time and go and get that. And I have to call time to string, but I can pass in now time inside of there, and it will output the current time. And likewise, let's go paste that in there. I can also get the current date. So date like that. And you just need to change this to date to string with now time again. And let's say we wanted to get the day, the current day. Well, go like this. Then you're going to call day of week, and again, pass it now time. And another thing you're going to be able to do is decode a date to years and months and days. So we can go decode date, and date is going to return the current date. And then we want this year, month, and day. And another thing you're going to be able to do is encode your year, month, and day to a t date time value. So I am going to also, why don't I show you how to do formatting here, formatting output. I'm going to show you two different types of formatting output. So I'm going to say write line like this. And I'm going to say today is and format date time. And let's say I want to get 4 letters for our month, 2 for date or for the day, and then 4 for the year. Do it that way. And then we can call encode date and y, and d. And I also said I was going to show you another formatting option. You can just say write line like this and call format, and format can be used for, outputting any type of information. So today is like this, and if this is a decimal or an integer, you put AD. You're gonna have to put a / for the representing the date, and then another one, right like that. And then the values you want placed, the first value you want placed right here is going to go right here first, so D. And then in the second block, you're going to have your month and year like that. Boom, like that. and run it. And there you go. Whoops, got rid of it there. There it is, it's back. And you can see the current date and the day and all of that additional information. All right, so there you go. That is how we work with dates inside of Object Pascal. And up next, I want to show you how we can work with functions. All right, so I created a new project, and now what I want to do is come in and set up a couple variables to use before I start covering functions. So I'm going to go W, X, and Y, and these are both going to be integer types, and I'm going to put them on a second line here just for neatness. And then I'm also going to have result, which is what I am going to use for passing values back from said functions. And we can save this. All right, so good. Now, Pascal has both procedures and functions. And how they differ is that procedures don't return a value, but you can pass values by reference, as I'll demonstrate. And functions do return a value. That is, they have to return a value. And basically, arguments are going to be created when the function begins execution, and then they're going to be destroyed after execution, which I will also demonstrate. So let's just create a function. So we go function, and I'm just going to call this getSum. And what you're going to do is just define a name with function, and then you're going to have your parameters. So I'm going to say I get num1 and num2, and both are going to be integer types. So integers, there you go. Then after that, you put your return type, which in this situation is going to be integer, and then you throw in a semicolon. Then you surround everything with begin and end, and what I'm going to do with this is what is going to be returned is actually you use the function name, getSum like that, just like getSum right that, and then you go num1 plus num2. There you go. Just as simple as that, you created a function. Now, down inside of our main application part, right here, I am going to go and give W a value of 5, and I'm going to give X a value of 4. Then I'm going to say result is going to be equal to getSum W and X. And then I can come in and say right line. And let's just keep it simple and just say sum like this. And then follow that up with result. Just like that. All right, so let's go and run it. And there's an error. What's the error? Oh, I forgot a parenthesis. There you are. Fixed, and run it again. And what else did I forget? See if you remember. Read line. There you go. And if we run it again, there you can see sum comes back as 9, and 4 plus 5 is equal to 9, so we know that that is all good. And I just hit return, and it went away. All right, so there is a simple function. Now let's cover something more complicated. So up here, again, I'm going to create a new function, and this is what we call a recursive function. And a recursive function is a function that calls itself. And the way factorials work, they work great whenever it comes to demonstrating how recursive functions work. So that's what I'm going to use. So let's come in. Again, what are we going to do? We're going to say begin, end is created. Then with a recursive function, you always need a condition inside of your recursive function that is going to stop calling the function. In our situation with this, it's going to be whenever num is less than or equal to 1. Well, then in that situation, we're going to say, again, this is the return statement from the function, same as the function name. This function is going to return a value of 1. Else, if it isn't, we are going to go and calculate factorials. And I'll explain how factorials are calculated here in a second. So I'm going to get the number times, and then call the factorial function again by passing the number minus 1. See, it's going to reach a point in which, as the number decreases, no matter how big it is, eventually it will get to the point in which it is equal to or less than 1, and in that situation, it will return 1 and stop calling the factorial function. All right, so simple. Now I'll come down here and go and show you how to use it. So once again, I'm going to say result is equal to factorial. And let's get the factorial of 4 because it's very easy to figure out. And then I can just go right line factorial of 4 like this. And then print out our result. And then I'll explain exactly what a factorial is. So there it is, comes back as 24. All right, so what exactly is going on with this? Well, I'll show you. Whenever we first call our function, it is going to receive a value of 4. What is it going to do then? Well, it's going to go and subtract 1 from it, as you can see right there. Let's see if I can get these on the screen at the same time. Yes, I can. All right, so the value comes in at 4, and what do we get? Well, we end up going right here, and it ends up being 4 times whatever the factorial of 3 is. 3 comes in here, and so we know 4 right now. We don't know 6. So what's going to happen is the 3 goes down right here. Again, we subtract 1 from it, and we know 3 is right there. We still don't know this number. Then we pass 2 down inside of here. We pass 1 into the factorial function, which returns a 1. This is where 2 times 1 comes from, because this is where the 1 comes from. So we get 2 times 1. This value of 2 jumps up here. We multiply 3 times 2 to get 6. That value of 6 jumps up here, and that's how we get our final factorial value. All right, so there is a demonstration of recursive functions. And we're going to do more with functions as the tutorials continue. I also want to, however, talk to you about procedures. And I'm going to show you exactly how to go and return values. So how you do it? Let's call this getSum3. I'm going to have x, y, and z. And they are all going to be integer types. And then I'm going to say var sum colon integer like this. And then what it can do, again, what are we going to do? We're going to say begin. And sum is going to be equal to x plus y plus z. Right, like that. Okay, so, oh, and I have an error here because I should have put a semicolon right there. All right, as well as a parentheses there. Okay, so there is our procedure. Now let's come down and call it. So down inside of our code section, what I can do is that W in this situation is going to end up being assigned the value of sum in our procedure. So I can call getSum3 like that, pass in 1, 2, and 3, and W is going to give our result. And then I can just come in and go right line and sum right like this. And then whatever the value of W is, which is passed back. And if we run it, you can see once again, sum is equal to 6. 1 plus 2 plus 3 does equal 6. So that works also. And this brings us to the concept of global as well as local variables. So what I'm going to do is I'm going to try to change a value inside of a function and show that you cannot. I'll just use a procedure because we're doing procedures. Doesn't matter, same thing. All right, so I'm going to say print number, and what print number is going to do, I'm going to have var inside of here, and you can also define, this is the definition of local variables in this var circumstance. So I'm going to have W like this, integer, and there we are. So that is local to print number. Oops, shouldn't be here though. I have to take this and throw it up above. All right. So come up here, outside of here, and inside there. All right, procedure. And we can go and tab these back if we want. Doesn't matter, but just to be neat. Okay, so there is our procedure and our local variable. What do I want to do now with our local variable? Well, I'm going to say begin. And what I'm going to try to do, well, I'm going to go and assign W is equal to 1, exactly like this. And then I'm going to say write line like this, and I'm going to say in print num W is equal to what? Well, I'm going to get the value of W, throw it right there. Okay, So now that I have that set up, I can come down into the main code area, and here we are. And I'm going to go W is equal to 2. And then I'm going to say right line, and I'll say outside print num W is equal to, and W in that circumstance. And then I'm going to call our print number procedure, which is going to try to change the value of W. And then I'm going to go and call this again to see if the value of W changed. What's your guess? So I'm going to say outside print number equals W. Okay, it's going to do it twice. So let's go and run that. And if we do, we see that outside print number W is equal to 2. We then have print number W is equal to 1. However, whenever we go out of print number again, it goes back to its original value of 2. Why is that? Well, the reason why is it never was the same W. This W is local to print number. And if you don't remember, I said any variables that are created inside of functions or procedures die or are destroyed as soon as the function or procedure ends. So this W is a local variable to print number, and it's different from a W that lies outside of it. All right? Hopefully that makes sense. And we'll do more with functions as the tutorial continues, but now I want to talk about records. So a record is another type, a custom type. And what I want to do here is I want to define a record that is going to store information about record albums. So hopefully that's not confusing. So it's an album, and it's also a record. So what type of information is going to be stored inside of it? Well, I'm going to have a title for the album, and I am also going to have the number of items sold. So that's obviously an integer. And then we could have things like singer, which is also going to be a string, and lead guitar maybe, which is also going to be a string, and drummer, which is also going to be a string. Obviously, these can all be different data types. They don't have to all be strings because there's an integer right there to prove that. And maybe you have like an album ID, and let's make that a long int or something like that. Okay, so there is our album types. Now what we can do are our album custom data type. So now what we can do is down inside of var, these are going to be values that are accessible everywhere. I am going to declare some album records. So I'm going to say album 1 and album 2, which are both going to be of our custom type, which is called albums, or album, like this. All right, so there we are, album 1, album 2 of our custom type called albums. All right, so now we can come down here and start playing around with it. So come in here. Actually, before we do that, I'm going to show you how to pass an album into a function. Remember I said I was going to do more with functions? Okay. Or why don't we just do it with a procedure? So we're going to say procedure, and I'm going to call this album singer. And what it's going to do is it's going to receive a album. So call this album 1 of type albums, like this. And then, again, begin and right line. And then this is just going to print out the singer information based off of the album passed into it, which is going to be album 1, and it's just going to call the singer specific part of album 1, the album 1 record. All right, so let's come down inside of here and right there. So if there's any confusion about records, basically we talked about arrays. Arrays store lists of items with the same type with an index. Records, however, define groups of different types referenced by name. They're kind of like structs in other languages, if that helps you. Okay, so we already defined album 1, and now we can just very simply come in here and define the title. So we could do something like Nirvana, smells like Teen Spirit, all right? So here is our first definition. So we're assigning a value to the title for that specific album, We can also come in and say how many were sold, and that's approximately 3 million. And what else are we going to say? Whoops, there's no quote there. It's an integer, remember? And we could also come in and do singer. So let's do singer like this. And then we can go and put, there you are, Cobain. Okay, so there we are. We can continue to put in additional information if you would like to. One thing we could do is we can say, go and call directly for albums sold. So we'll do this and like this, and then we'll say album 1 dot sold, and there it is, and that will output that. And likewise, we can go album singer and pass album 1 into that function or procedure. I forget, they'll both work, and probably a procedure because there's no return. And you can see there I get album sold 3 million, singer Kurt Cobain. Okay, and the reason why there was no quote after that, let's look and see. Oh, because I forgot to put right line, and there it is. Now there will be a new line inside of there. All right, so a couple demonstrations of how to use records, and now I want to talk about something people find confusing, which is pointers. So basically, every variable is stored in memory, okay? Hopefully that's something that doesn't sound crazy. And basically, pointers store the address that holds the data assigned to a variable. That's what a pointer does. So let's go and define some. So I'm going to go up inside of type here, and I'm going to create pointers that point at addresses for different types. Very important, because the type has to match. So if this is a pointer that points at an integer, we're going to come in and define that, yes, it points at an integer. And we're going to do similar things for other types. So maybe this is a pointer that points at a double. Well, we come in and we define it's a pointer that points to the double. You have to do this. If it's a Boolean, it has to be a specific pointer that points at a Boolean. That's how this all works. And we can move this up here so we can fit this in a little better. And we can also, I'm going to go and define pointer here. And this is also going to be pointed at an integer. And then I'm going to define an array, because we're also going to deal with pointers and arrays and how they can interact with each other. So of type integer, like that. Okay, so we have all of those defined. Now what we can do, down inside of our variable section, we can assign pointers to these. So I'll say my int and integer. So we're going to have this guy is going to be pointed at, and then I can say my double is going to be a double, and my bool is going to be equal to a Boolean, and then we'll assign pointers to these individual variables. And then I'll have my array, which is of type array. We then have to declare our pointer variables. So I'm just going to pi underscore pointer and I pointer. So there that is. And do the same for the double one. And D pointer. You can see exactly on the screen exactly where they are. And I'm going to do another one for Boolean, which is B pointer. And then another one for this array. So pointer A pointer, like that. Now I'm also going to define pointer ADD, and this is going to hold a pointer for an address. And you can just go word. I'm going to use word for this. Use uppercase if you'd like. And I think that's good. Also going to come in here and I'm going to define a function that is going to receive a pointer and then get the pointer value. So let's just come here to the end of our last one we created. So right here, and I'm going to say function, and it's going to be called get pointer value, and it's going to be passed a pointer. There is my custom data type, and it's going to return a integer. So everything's the same. I can define a custom variable inside of here. I'll just call it val, which is of type integer. And then, of course, we have begin. And then if we want to pass a value back, we use the same variable name as the function name. And to go and get that value, you just say p with the caret symbol like that. And there you are. Now, down in our main code section, I'm going to go and interact with these different pieces of data. So what am I going to do? Well, I'm going to take my int, and I'm going to define it has a value of 10. I'm going to have my double and say that it has a value of 3.14. I'm going to have my boolean, which is going to have a value of false. And I'm going to go and initialize with W here in this situation. I'm going to go from 1 to 5 and assign values to this array called my array. So W, it's just going to be whatever the index is, right like that. Boom, 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 boom. And there we are. Okay, so now what am I going to do? Well, I'm going to assign the address of the variable using what is called the address operator. So we have iPointer, and this is the address operator, the @ sign. So my int. So it's going to get, my int. So it's going to get the address for the value in memory where the my int value is stored, and it's underscore, right, like that. Okay, so what else are we going to do here? Well, I'm also going to do the same for our double. Exactly the same. Again, that's the address operator, and my double like that. If I can spell double. There we are. Okay. And then boolean. Again, pointer like this, and equal to, and again, my bool. And again, with our array that we just initialized here, and my array. There we are. Now, if I want to get the value, I use what is called the dereference operator. So this is called the address operator, and in a second, you're going to see the dereference operator. So I can say right line like this, I_pointer, and there it is. There's the dereference operator, that caret symbol. So I'm trying not to hit you with jargon over and over and over again. Okay, so there we are. And we can go and get the value for each of these. So this is just simply D pointer, this is B, and this is A. All right, you'll be interested maybe in exactly what value you get with the array pointer because we are pointing at it. Well, one thing is you're going to get the very first value, if you're wondering. I want to show you, however, before we go and actually execute this, is that you can actually increment to the next value in the array. All you do is go increment, just like we used increment before. And then you go pointer, like that. And then we can go and print out our next value in the array for that. And then we can also decrement. So let's just go and copy this. And you're going to see that whenever we do that, that it is going to show the first value in the array. Another thing to be aware of is that it is very common to assign nil to a pointer variable, especially if you do not have something assigned to it, and that's how you assign nil to it. And on top of that, let's say that I would want to print the address of the pointer. Well, we're going to say pointer add like this and equal to. Well, to do that, I just go address addr for, and I'll just use iPointer in this situation like that. And then what I can do is I can say that I want to print it if the pointer does not have a nil value. So I'll say point like this, and that's not equal to nil. Whoops, nil like that. There we are. And then we have to say then, and this is, I did this wrong both ways. Let's just go like this, address, and let's just get rid of this whole thing. All right, so it's iPointer like that. All right, so I got that right now. And what else? Let's do this. And then I'm going to say right line and pointer, add like that. Close it off, close that off. And the very last thing I'm going to show you is how to pass a pointer to a function, which we covered before. This is the function that we had. This one, get pointer value, gets passed a pointer, and what's it do? It uses the, what's this called? Dereference operator to get the value for the pointer that was passed inside of there. So I'm going to call that function just to show you that I can print it. So how do we do it? Well, I'm just going to go right line like this, and I will say pointer val like this, and call it. And it's just called get pointer value and pass I pointer. Right like that. And run it. Boom. And you can see here that we were able to get all of those values that we stored from the pointer. And you can also see we were able to get them from, this is the address where the value was stored. It's probably going to be different than what I have. And here is the pointer value that was returned from our function. So all neat stuff. Hopefully pointers weren't that confusing. They're just addresses. That's all they are. So please don't let them confuse you. Now what I want to do is I want to show you how to work with ANSI strings. So we're just going to come up past the functions that we went and created here. Let's move that over. All right. So we're going to go into our var section right here. And I am going to just go string 1, string 2, string 3. And I am going to define these as ANSI strings. And there's different functions that you will be able to use with them. So go back down into our coding section here. Right here. Looks good. And let's go strings like this, just so you can see what we are dealing with here. So, or you could actually say ANSI strings. Okay. So here we are. What are we going to do? Well, I'm going to go string 1 is equal to, and I'm just going to go random like that with a space. String 2 is going to be equal to, and I'm going to say words like that. And then I'm going to do the same thing for string 3, and you're going to see why in a second. So there we are. We have 3 strings that we created. Well, you can concatenate strings. How you do that is you go append string like that, and string 1 and string 2. There we are. And that's going to work. And I'll show you what I mean by concatenate whenever I go and print them out. Just joins them together. That's all. Nothing that fancy. What else can you do? Well, you can get the string length, meaning the number of characters that is inside of the string, right like this. And then you just call length, and you pass in whatever string you want to work with. All right? So there that is. What else do we want to do? Well, you can compare strings. So to do that, I'm going to go ANSI compare text is, to do that, I am going to call right line like this, and then call ANSI compare string like this, and pass in string 3 and string 2. Now this guy is, these are the strings. And if this comparison, if the first one is less than the second one, you're going to get a value of -1. If they're equal, you're going to get a value of 0. And if the first is greater than the second, you are going to get a value of 1 returned to them. And why don't I just do one more because it's very simple. Oh, another thing is if you would like to compare and have it be case insensitive, you would use ANSI compare text like that instead of ANSI compare string. And I'll do one more thing here. Let's say that I want to do right line and I want to display in uppercase. I just go ANSI and uppercase. Oops, I'm going to do case like this, and then pass string 1 inside of it. And it'll print it out with all uppercase letters. And I think that's the vast majority. And if I run it, you're going to see that it concatenated those values. We've got the length, the number of values. We got 0. That means the two strings were equal to each other. And there you are. So cool stuff. Whole bunch of stuff about strings. And now I want to talk about variants. Now, a variant is going to be assigned its data type at runtime depending upon the data stored. And you can use any of the simple types with a variant. You can't, however, use container types like arrays and things like that. So what we're going to do is inside a var, I'm just going to go my var like this and define it as a variant. And while I am here, a variant, it's A. Okay. And while I'm here, I'm also going to show you how to store information in files. So I am going to declare those needed values. So I'm going to have my file, and the file you're going to be storing in, you refer to it, or you define that it's a text file, like that. And then we're just going to have a file string, which is just going to be a regular old string, right, like that. Okay? So just remember that, because we're going to cover variants very quickly and then jump right into saving files. We'll jump back down into our code section, and here we are. So first off, we're going to do variants, and then after that, we'll do file IO, like that. All right, 2 things in a row. And how do you go and define a variant? Very simple. You can see that I am going to be able to assign this the value of my int. I'm also going to be able to assign this the value stored in my double. And you're also going to see that I'm going to be able to store inside of it my bool. And you don't just work with variables. You can put regular old, you could have a 1 here, 3.14, and a true there, and they're also going to work. And I'm just going to run this just so you can see that there are no errors. All right? So that is how variants work. Now on to file IO. Now you are going to be able to write any type of data to a file and retrieve it. What I'm going to do is show you how to store text, which is the most common thing. So the very first thing you're going to do is you're going to call assign file, and we're going to open a file for writing, and we're going to write to it, and then we're going to close the file. So you go assign file, and I'm going to use the text file. That's the data type I'm using for my file. If you remember, a couple seconds ago I made that. So, and then I need to point at where I want it to be saved. I'm going to point it to a text file called my file text. It's going to open that file, create it if needed, just write to it, and then if we want to write to it, just go my file like this, and then we can go write line and use my file like this, and whatever you want to write to the file. So I'm just going to say some random words. This is what I am writing to our file. And then after I do that, I'm going to say close file like that. And this is the file that we have here. All right. And what I'm going to do now is I'm going to open the file in read mode so that I can read it. How do you open in read mode? You call reset my file like that. And then let's go and cycle through the lines that are inside of the my file text file. How you do that? You go while like this, not, and EOF, end of file. So we'll continue cycling as long as we don't reach the end of our file. And as we cycle through our file, what do we need? We have multiple things going on, so we need a begin and end. Well, I'm just going to use readline. So it's very simple. I use the same type of functions that do multiple different things. So what am I going to do? I'm going to say, hey, my file, I want to read information from it and store it inside of file string. And then after this, I can go and write that information that I got. So I'll go file string, right like this, and close that off, close that off. And then after we read all of them, we can go and call close file like this, and my file again. There we are, and there we are. And if we run it, you're going to see some random words. So we wrote some random words to the file, and then we read them back and printed them on the screen. There you are. It's just to be kind of a little bit more completionist here. what I want to do next is show you some different things we can do with files. So let's go, and if we want to check to see if a file exists or not, well, we can just say if file exists and then pass inside of it my file text. That guy right there. All right, so if the file exists, what do we want to do? Well, let's just say we want to print out that the file exists. I don't know, file exists if it does exist. And we know it does exist, so we'll just do that. All right, just to keep it simple. You can also come in here and why don't I just copy this like this, and then I'm going to delete the file. I can delete files also. So delete file. The file I want to delete is called my file text. There it is. There you are. And there we go. So that deletes it. Then I can say if file exists, print that it exists, and if it doesn't, else in other ways. Otherwise, I'm going to say, let's just copy this so I don't have to paste it in there. Okay, like that. And else, if it doesn't, then I can say file is missing or something along those lines. And let's continue on here. What other things would I like? Well, you can create directories using Pascal. So let's go and get the current directory actually first. So I'll say right line, and if I want to get the current directory, let's just go directory like that. And I guarantee you it's probably going to be different. Yours is going to be different than mine. Just like to tell people that. So get current directory, and it'll get it. If I want to create a directory, so I'll say if and create directory. Let's call it sample dir like that. Then if I created it, I can say right line and directory created. So there it is. Created that directory. Another thing we can do is do almost exactly the same thing to remove a directory. So we might as well just have it be the same. So I'm going to go paste that inside of there. Let's scroll down a little bit. And I'm going to say if, and I'm going to just change this from create to remove directory. And sample directory, same thing. Directory deleted. And now that is going to run, and we can run this. And you'll see that this is the home directory. Remember, I said it's going to be different than yours. Directory created, directory deleted. All right, so neat stuff. And now what I want to do is talk about classes and objects. All right, so now we're going to talk about working with classes and objects and polymorphism and all that. So this is a custom type, so we put it in the type section. And what I want to do here is define a shape class type. And normally it is common for there to be a T at the beginning of all of your shapes. So, or all of your classes, I mean. So how you define it is you just say class, like that. Now, you can have private data. So you just type in private like that. Any data that is listed as private is not going to be available to your subclasses. It will only be available in this specific object and only accessible from functions within this specific object class. Okay, what we're going to use is we're going to use protected. So protected can be inherited by subclasses. So shape is going to be the superclass, and you're going to inherit all of the different fields or variables inside of this class to another class. And that's how I'm going to demonstrate inheritance as well as polymorphism. So I think that makes sense. So I'm going to say protected. What values are going to be protected? Well, I'm going to have a height. I am going to have a width. And they are both going to be of type double. Then you have what are called public. Mainly, I'm going to have a constructor function that is going to be called create, and it's going to be called every single time you create a new shape. And I can move this up so you can see everything here all at one time. What else am I going to have? Well, I'm going to have a destructor, which is going to be called every time you want to destroy your objects and free up memory. I'm also going to say that this function can be overridden. So I'm going to say override with it as well. So whatever, if you want to do special things with the destructor, you can mark it as override, and you can do that. Another thing you can do is you can have procedures and functions inside of your class. And what this is going to do is it is going to set the values for our objects that we create. It's going to get a height and a width, and they will both be doubles. And I'm also going to mark this as overload. And overload means that you can have multiple different procedures or functions with the same name, but with different parameters. And it will automatically go and create them. So let's say I wanted to be able to create shapes that also only have a width, like a circle. Okay, I can do that, and there we are. So now we're able to work with different types of shapes. What else can we do here? Well, any shape is probably going to be able to calculate the area. So we'll have area here, and it is going to return a double. And I'm going to mark this as virtual. And what this is going to do is I'm saying that I want this specific function, being marked virtual, to be able to figure out what version of area to call at runtime. Because we have different shapes, and we're going to have different areas, and I want to be able to calculate different areas depending upon what type of shape I'm working with. All right, so there is a whole bunch of stuff there. Why don't I just jump right into inheritance to cover that? So you can actually create a class that's going to inherit everything from this shape class that we have up here. Very easy. So let's say that I want this to be called circle. And how you inherit all of the shape classes information is just typing it like that. Pretty simple stuff. Whoops, I'm in the habit of putting a semicolon there. You don't do that. I'm going to have only public pieces of information inside of here. And what we're going to do is we're going to designate that we want to override area because this is a special type of shape. It's a circle. So inside of here, I'm going to say function, and I'm going to give it the same name. And I'm going to override it. It's still going to return a double. And I say override like this. And let's say that I never, ever expect the area to change, even for classes that inherit from my circle class. And I want this to be the final version of area. I don't want it to be changed ever. I just mark it as final, like that. And that's all I'm going to do for the circle class. That's why I just jumped right into it, because I didn't think it would be confusing. Now what we need to do is we need to come in and define all of these functions. These are all functions. The constructor, destructor, these are procedures, and area. So I need to, outside of there, define what all of those functions look like, or what they do, actually. So first one I'm going to go and create is our constructor. This is going to be called every single time we create a new object of type shape. So I'm going to call T-shape, if I can spell shape right, T-shape like that, and the name of the function is create. What's it going to do inside of here? Well, it is just going to get, because it didn't receive a height and weight, it's going to define the height as being equal to -1 to designate that nothing was provided, but we want to assign a value, and the same with our width. So if they do not put information in regards to height and weight, well, we are automatically going to go and create it for them, but not assign anything. What other functions do we need to create here? Well, let's say that we want to go and define what happens with our destructor. We can go destructor like this, and again, T-shape to say what class it's assigned to, and destroy. And like this. And I'm not going to do anything with this, But commonly what you would do with a destructor is, let's say you had other objects inside of your object. Well, in this, you would no longer need those objects, because if your object that has objects is destroyed, well, then you can also go and destroy the objects inside of it. Hopefully that makes sense. All right, because they're no longer needed. All right, what else are we going to do? Well, we're going to go and define set values, and it is a procedure. As you can see right here, see, that's what I defined, set values, and there's 2 of them, and then there's also area. So we're going to go and create all of those. So what's it going to do? Well, again, you have to say what class it belongs to, T-shape, set values. It's going to be like this, and it's going to get height and width automatically went inside of there. Good stuff. And what am I going to do? Well, I'm going to use a special keyword called self. And what's self? Self is like this in other programming languages. It basically allows you to refer to the object with a name, and the object doesn't have it yet. See, we create the classes before we create the objects, so there's no way to refer to them by their name. Hopefully that makes sense. So I'm going to say self, and height is going to be equal to whatever the height was that they passed inside of it. And I'm going to do the same with the width. So I will change this to width, and that will be whatever the value of W is that was passed inside of it. But remember, I had 2 set values. So I'm going to go and get this, and I'm going to come down here, and I'm just going to go set values. But in this situation, I only receive width. I don't get this other one. So I'm just going to go get this, throw that right there. And there we are. So now we have a set values that has width and one with height. So I'm going to go like this and like that. Okay, I'm demonstrating this in multiple different ways. It actually makes more sense to go and inherit and create a circle class that doesn't receive it. So I'm doing it in multiple different ways just so that I can demonstrate how to do different things. So that's why I'm doing it this way. You would never do this in real life, but this is a tutorial. This is not real life. So, all right. What else do I want to do? Well, I need to calculate area, and that was defined as a function. So I'm going to go function, T-shape, and area, like that. And it's going to return a double. Whoops, double, like this. There we are. Sometimes this thing gets ahead of itself. All right, so what are we going to do here? Well, remember, I'm going to make this work for circles, even though I have a circle inherited and so forth. So what I'm going to do is I'm going to say if height is equal to -1, well, then in that situation, what I'm going to do is I'm going to say the result is going to be equal to 3.14159 times, I'm going to call my power function, so power and self, whatever the width is, divided by 2, and to the power of 2, like that. And, whoops, get rid of that semicolon. Else, I am going to come in and say that, let's move this over so that it lines up nice. There we are. Result, which is good, what I'm going to return here, is equal to, and again, this is just going to be self, height, because it's just a regular shape, and like a square or a parallelogram or a whatever, and height times width. All right, so there you go. I defined all of those functions. But I also have an area that's specific to circles. So let's create that also. So I'm going to say function, and it's part of the circle class, and it is area, and it also returns, it does that all the time, and it returns a double. All right, so I got that. Jump down inside of here, and what it does is it just goes result, doink, doink, like that, and we can just go, you know what, let's just copy this so we don't have to type that out. So copy that and paste it inside of here, right like that. All right, so there we are. Got all of those functions created, and that's it. That's all we're going to do. Now down in the variable section, I have all those classes defined. I'm going to go variable first off, and then I'm going to say my shape, and it is going to be a T-shape like that. I'm going to define another one. It's going to be called my circle. It's also going to be a T-shape. And another thing, you can actually either go circle 2 like this, and then use the circle specific class that you created. But because of polymorphism, you can just call this a shape, and it's still going to call the right area function, which you'll see here in a minute. So down inside of our code area, let's go like this, get rid of that right there. What I want to do, if I want to create a new shape object, I just go my shape like that is equal to t shape and call our constructor or our create function, whatever you want to call it. Then I can say my shape like this, go call the set values function. Maybe we pass 10 and 10 inside of there. And we can say right line, and let's go and get the area. So we'll say area is going to be equal to go and call the area function, you just go my shape like that, and area, and to string like this, and there you are. You're going to be able to calculate the area for it. Now, if you no longer need an object and you want to delete it, just go my shape and free like that. There you go. You just created an object, found the area, and then deleted it. Now let's create a circle shape. So I'm going to go my circle, again, equal to, and t shape. Call the create function again. And then what do we do? My circle. And I will go and set the values, and it's going to call the right constructor function for me if I only pass in 10 or one value, and that'll be defined as the width. And then I can say right line like this, and the circle area like that. And can I spell circle the right way? Yes, I can. All right, circle. There we are. And let's get rid of that extra quote, throw that one in there like that. And then to get the circle, just go my circle and area and to string like that and like that. All right, what else do we want to do? Well, I no longer need my circle, so I'm going to call free on it to free that memory also. Let's continue. What else do I want to do? Well, I want to use my inherited type, so I'm going to call this circle2. And it is going to be, this is how we define that we want to use the T-circle, even though we called it a T-shape. See, circle 2, we called it a T-shape, but it's actually a T-circle. All right? This is where we define it, and this is the reason why the area function works. So, call create on it. It's going to work for us. And this is polymorphism. Even though the function has the same, or the object is looked at as a shape, we know it's an actual circle, so we will call the circle version of area instead of the shape version of area. And I showed you before how we were able to override those different things. So I'm going to say set values, and I'm only going to pass 5 in because that's all we got. And I can say right line like this, and circle to area like that. And then if I want to go and get my circle 2 area function, it's automatically going to call the circle version of it instead of the shape version of it. I can go print that out, and that is it. And if I run it, let's see. Oops, guess what I forgot? Read line like this, and run it. And there he is. And you can see we were able to find the area of a generic shape, the area of our circle using the shape version of area, and then I changed the area with our actual circle objects. So there you go, guys. A rundown of the vast majority of the Pascal programming language, sampling of Delphi here. And if you guys want to see how to make GUI interfaces and mobile apps and such, tell me in the comment section. If this video gets a half decent number of views, I will make it. And like always, please leave your questions and comments down below. Otherwise, till next time.